Okay, please try guided practice number 4. Find the value of x. All right, so we don't have any vertices or points given, so we'll just go right into the numbers. It's going to be the external segment, which is 1, times the entire segment, which is 3 plus 1. And that is going to equal x times x, or x squared. All right, 3 plus 1, of course, that's 4. And 1 times 4 is just 4. And that equals x squared. The opposite of squaring something is to take the square root of both sides. Square root of 4 is 2. And that equals x. When you do square root of both sides, you're supposed to do plus or minus, because negative 2 squared would also equal positive 4. However, x, we can see here, is a length, okay? So we're going to discard or throw away the negative answer and just keep the positive. So x equals 2. All right, please try number 5. Once again, we take the external segment, that's 5, and multiply by the entire segment. That's going to be 5 plus x. And that equals this times itself, 7 times 7, or 7 squared. Distributing 5 times 5, and 5 times x. And that equals 49. Okay, here we have positive 25. The opposite is negative 25. Cancels here. Bring down your 5x. 9 minus 5 is 4. 4 minus 2 is 2. And this is x times 5. The opposite of times 5 is divided by 5. So that's it, 24/5. If you wanted a decimal, this would just be 4.8. All right, because it doesn't repeat. So 4.8, that answer makes sense. All right, please try number 6. Okay, we have the external segment, that's x. And that's times the entire segment, so that's going to be 10 plus x. And that equals the tangent segment times itself, 12 times 12, or just 12 squared. Distributing x times 10 is 10x. X times x is x squared. 12 times 12 is 144. Okay, we need to factor or use quadratic formula. Either way, it needs to be equal to 0. So I'll put the greatest exponent first. I'll put the x squared plus 10x. And I'm going to do minus 144. On both sides. Okay, so on this side on the left, we still have negative 144. And 144 minus 144 is 0. All right, let's see if we can factor 144. It's actually negative 144. And see if we can find a pair that adds to positive 10. So this would be negative 12 times 12. That won't do it. If I take half of 12, that's 6. And I double negative 12, that's negative 24. That won't do it either. All right, we need quadratic formula. Negative b plus or minus radical b squared minus 4ac all over 2a. All right, so negative b is going to be negative 10. I better do it over here. Plus minus radical b squared, that's going to be 10 squared, minus 4ac. A is 1, and c is negative 144, all over 2a, so it's just 2 times 1. All right, this is going to be negative 10 plus minus. I'll do this calculation on the calculator, and I get the square root of 676, whole thing divided by 2. Okay, let's see. We have negative 10 plus minus square root of 676 is just 26. And that's divided by 2. All right, negative 10 plus 26 is 16. And that's divided by 2. Negative 10 minus 26 is negative 36. And that's divided by 2. 16 over 2 is 8. Negative 36 over 2 is negative 18. Now, if we look here, x is a length, okay? So this one gets thrown out or discarded, and x equals 8. By the way, it looks like I could have factored if I had kept going. Okay, I didn't realize it, but we could have done, in order to get positive 10, it looks like we could have done 18 and negative 8. If we did 18 and negative 8, that would have worked in place of positive 10. So if I kept factoring, it would have worked, okay? But I thought that it wouldn't work out to a whole number or an integer, so I used quadratic formula. All right, I'm going to skip 7. It looks just like the other ones. All right, please try number 8. Pretty simple. We have 9 times 16. And we have x times 18. All right, so you just take the product of the segments of each chord and set them equal to each other. The opposite of times 18 is divided by 18. 18 over 18 cancels. Let's see, 18 divided by 9 is 2, and 16 divided by 2 is 8. All right, please try number 9. We have the external segment, that's x, times the entire segment, that's going to be x plus 29. All right, make sure you use parentheses. And that equals the external segment, that's 18, times the entire segment, that's 22 plus 18. Distributing, x times x is x squared. X times 29 is 29x. And 22 plus 18 is going to be 40. Okay, let me see. 20 times 40 is going to be 800 minus 80. That's going to be 720. Let me double check. All right, that's correct. We need to set this equal to 0. I'm going to do minus 720 on both sides. And it cancels over here. All right. X squared plus 29x minus 720 equals 0. Let's see if we write out the factors for 720. This is a tough one. It's actually negative 720. We're looking to get positive 29. So 72 times negative 10. Definitely not. Those are too far apart. And what if we did negative 20? We'll double this one and then take half of this one. 36. Those are too close together. Let's see. What about negative 15? And this would be 48. 48 minus 15. That won't do it. Let me see. Okay, got it. I tried negative 16. Negative 720 divided by negative 16 is 45. Add these two, and you'll get 29. So I lucked out. All right. So we're going to have two binomials here. X times x is x squared. We're going to use positive 45 and negative 16. All right. So just to make sure, 45x minus 16x will give us 29x, so it works. All right, so when you set this equal to 0, that means either one of these can be 0. So x plus 45 is 0, and x minus 16 is 0. And in this case here, x is negative 45, and x is positive 16. I'm thinking the negative one will be thrown out because x is a length. Okay, so we can't use the negative one. X is 16. All right, so unlike last time, I just tried to keep factoring. And I actually got it. All right, word problem, but they gave us the diagram. It says Tethys, Calypso, and Telesto are three of Saturn's moons. Each has a nearly circular orbit of 295,000 kilometers in radius. Okay, and the Cassini-Huygens spacecraft entered Saturn's orbit July 2004. Telesto is on a point of tangency. Find the distance dB from Cassini to Tethys. All right, Cassini to Tethys. Here's Cassini. And here's Tethys. All right, so we're looking for this entire distance right here, dB. Let me blow this up. All right, we're looking for this entire distance, dB, but we're given this portion here, so I'm just going to call this portion x. All right, so we said this here, the external segment, which is 83,000, times the whole thing, which is x plus 83,000. So 83,000 times x plus 83,000. And you know what? I think I'm doing this the hard way. Wait a minute. Okay, I have a better idea. Since they gave us this portion, we'll just call the whole thing from B to D, we'll just call that x. This way we won't have to add. So the distance from B to D, which is what we're looking for, is going to be x. This way we don't have to add x plus this. That makes it a lot easier. All right, so the external segment is 83,000. And that is times the entire segment, which we called x. So we're just going to do 83,000 times x. And that is going to equal the tangent right here times itself. So 203,000 squared. All right, so it's actually an easy problem. It's just big numbers. The opposite of times 83,000 is divided by 83,000. Cancels here. We'll do this on the calculator. Make sure you square the numerator first. All right, I get a big decimal. I'm just going to do nearest whole number, so I have 496 and 494. Okay, the decimal was, on the end, the decimal was 3.975, and it kept going. So since the 9 was more than 5, I rounded the 3 up to a 4. So that was the last number. Okay, and these units were in kilometers. So this is just in kilometers, km. Final answer.